Alright, in chapter 1.6, this is solving linear inequalities. This is something that you all should have done in Algebra 1, but we'll go through it anyway. The first example is just a quick review on how to graph inequalities on a number line. And the first example has two parts. Part A says to graph x less than 2. So what I like to do is I like to put three numbers on my number line. I like to have the number that we're graphing right in the middle. I like to have a number to the right and a number to the left. And what we do is we're going to be putting a point at 2. But anytime it does not have an equal to mark, we're going to have an open circle because this is less than but not equal to 2. Okay, and then less than, if you think about it, less than means all values that are less than 2. So all values that are smaller, so there's going to be all values to the left of 2. And if you look at this, this is saying that x can be any number as long as it's less than 2 but not equal to 2. So 1.99 is okay, 1.999 is okay, but once you get to 2, that's not alright. Okay. Example B, pretty much the same thing. We'll have -1. A number to the right is 0. A number to the left is -2. This time it does have the equal to mark. So instead of an open circle, we're going to have a closed circle, meaning that it includes that value of -1. And if you read this, it says x is greater than -1, which means it's going to be all values that are higher than -1, which is all values to the right. Okay. So when we get to solving these, actually the next thing we got is another graphing question, but when we get to solving these, we'll have to be able to solve and graph these. Okay. Example 2, very similar to example 1, except for these are what are known as compound inequalities. This one is known as what's an AND compound. This is an OR compound. Okay, they're a little bit different, but they got the same concept here. So this one looks a little complicated, but if you read kind of from the middle out, it's not that bad. So I'm going to include -1. I'm going to include +2, and then put some of the numbers that are missing in the middle here. Sometimes, you can't include all of them, so just put a few numbers in there so you can see what's going on. If you wanted to, you could put a number to the right, to the left. It's up to you how many numbers you need, and depending on the case. But if you look at it here, I'm going to look at just this part here, x less than 2. So just like the last problem, that's going to be an open circle, and less than means to the left. Okay, so this one's going to be going to the left, but I need to look at the other part to be able to finish my graph. And since this is a compound inequality, it's an AND statement, so it's going to be less than 2, and then I'll read from this part. If you read from the middle out, this says x greater than -1. So at -1, I'm going to put an open circle, and it's greater than. So it's going to meet right in the middle. So x is less than 2 and greater than -1. That means it can be any value in between -1 and 2, but not including -1 and 2. B is an OR compound, very similar, but it should have a different look of the graph. I'm going to include 1 and -2, and then put a couple of values in the middle. This time I'm not going to put the values on the outer part. This one is an OR, so let's do the first one. It says x less than or equal to -2. So it's going to be a closed circle. Less than, we know, goes to the left. Or it could be greater than 1, which is an open circle. Greater than 1. Alright, so AND compounds look like this, OR compounds look like this. Alright, so when we get to solving these, let's go to the next page here. When we get to solving these, we're going to be able to solve and graph. So I've got 3 examples here. We'll try to go through them a little quick here because we can't have the videos too long. First one, example 4, says to solve and graph. So we're going to solve this just like we did in an earlier section. Pretend for a second this is an equal to sign. So I'm going to get my x's on the same side. So I'm going to subtract the 7x, and I like to keep my x's on the left-hand side. It just makes things a little bit easier for me at the end. So subtracting the 7x is going to get me -2x plus 2 greater than -4. And then to get rid of this plus 2, I'm going to subtract the 2 away. I'll have negative 2x greater than, and then negative 4 minus 2 is negative 6. And here's the part where you have to be careful. This is the only part that's different with this type of solving with inequalities. When you divide or multiply by a negative, anytime that happens, you always flip your inequality signs. This is going to be x, and then this is going to flip to a less than positive 3. So remember, always flip your inequality sign if you multiply or divide by a negative. So 3 is going to be in the middle, 2, and then 4 is an open circle at 3 because it does not have equal to, and it's less than, so it's going to be pointing to the left. Okay, number 5 is a compound. This is a and compound, so our graph should be pointing towards each other when we get done solving. So looking at this one, we work our way from the middle out. So pretend for a second we just had this part here. To solve this, I would know to add 10 to both sides. Well, this third part here is going to be doing the same thing. I got to keep my entire equation balanced. So what I do to two things, I've also got to do to the third side over here. So negative 4 plus 10 is a positive 6. The 6x is still left inside. 14 plus 10 is 24. And then to get rid of this 6, we're dividing by a positive 6, so we're not going to be flipping our inequality signs at all this entire problem. So 6 divided by 6 cancels to 1. 6 divided by 6 is 1 for here. And then 24 divided by 6 is 4. So this is a compound and inequality, so they should be pointing towards each other. Let's just verify that. So I'm going to put 1 and 4, and I can put two values in the middle there pretty easily, 2 and 3. So at x less than or equal to 4, that's going to be a closed circle going to the left because it's a less than. And then for x greater than 1, that's an open circle, meeting it in the middle. Remember, you can always pause this if you need to write these down, but I got one more example I need to get through. So example 6. This is an OR compound, so you can tell pretty easily that it's an OR because it's got an OR right in the middle of it. So we're going to solve both of these problems separately. So let's solve the first one. Subtract 5 to both sides. You're going to get 3x less than or equal to 6. And then divide by 3. So x is going to be less than or equal to 2. Or, let's solve the next one. Add 7 to both sides. And they cancel. So you're going to have 5x greater than or equal to 30. And then the last step, divide the 5 to both sides. And you get x greater than or equal to 6. So the OR compound should be going away from each other on the graph. So let's make our number line. Let's put 2 and 6. I don't want to put 3, 4, and 5, so I'm just going to stick a 4 right in the middle. That way you can tell what's going on. Both of these are going to be closed circles because of the equal to line. And it says x less than 2, which is to the left, or x greater than 6, which is to the right.